we're only going to do half of this section of notes today. We're going to do 5.3 today. We're going to finish up with 5.4 on Monday. Okay. Ladies, please. Okay, so here's what I want you to do. Okay. For both of these sets of numbers, I want you to compute the average rate of change, and I want to have you find the ratio of consecutive outputs. What that means is the ratio of the y's, consecutive y's. So average rate of change, what you're going to be doing for this one here, is change in y over change in x, using the point and the one below it for here. So I'm going to use these 2 points to find the slope between them at that point, average rate of change. 5 minus 2 divided by -1 minus 0, which gives us 3 over -1, which is -3. So that's what I want you to do here. In this one, you're dividing the y's. Taking the top one divided by the second one. So I would do 5 divided by 2. On the next one down, I would do 2 divided by 1 and so on. I want you to fill in both of these. No, I was just pointing out where it was. Okay, so that's what you should have for those numbers. First one, your average rate of change is -3, and your ratio of consecutive outputs varies. You get 5/2, -2, 1/4, and 4/7. On the second one, your average rate of change varies, -16, -8, -4, -2, but your ratio is a constant of 2. The top one, you plot those points out. The type of function that gives you is a linear function. The slope between every 2 points is a constant. That is a straight line. If you were to plot those points, draw them out, you have a straight line with a slope of -3. The second one is an exponential function. When your ratio is a constant value, you have an exponential function. It does not grow straight. There are many more things in this world that are modeled by exponential behavior than they are by linear behavior. Okay, so exponentials are an important thing to be able to work with. That's what most of this chapter is about, is exponentials and their inverse functions, logarithms. That's what the rest of this is about. That's why you do inverse functions at the same time you talk about logarithms, because exponentials and logarithms are straight up inverse functions, and they're like this. Okay, one is how you solve the other. So, exponential functions. Exponential functions are the form f of x equals a to the x. A is not a variable. A is a constant. The variable, if the variable is in the exponents, that's an exponential. Your base has to be a constant. Your variable is in the exponent. That's what makes it an exponential equation. Yes, there are functions where your variable is in both the base and the exponent. Ooh, you won't like those at all. Okay. A can't equal 1. Why doesn't A equal 1? Why don't we want to have the base be 1? No matter what the exponent is, it'll be 1. It's an extremely boring one. 1 to any power is 1. So we never use 1 as the base for an exponential equation. That's just a flat line. It's extremely boring and doesn't do anything. That's why you don't have 1 as your base. The other thing you cannot have is you cannot have a negative number as a base. A must be greater than 0. The reason is that you have to be able to connect the points. Okay, so if you imagine, you will, if you had -2, let's say you had -2 to the x was your function. So that means if x was 2, I'd have -2 squared, which is 4. If x is 3, I would have -2 squared, which is -8. And if I have a function, those points need to be able to be connected together. which means somewhere between those 2 points I have to have what? To get from 4 to -8, what do I have to have? I have to have a 0. How many times do I multiply -2 times itself to get 0? Because that's what that function is. Remember, an exponential function is that base times itself. Can I ever take -2 times -2 times, no matter how many times, if I take -2 times itself, will I ever have 0? No, because the only way to get 0 for multiplication is you have to have 0 be one of the numbers you're multiplying, and -2 will never be 0. So -2 to a power will never be 0. If I can't connect these 2 points in my function, I don't have a function. It'll have, you can't, it won't work. So that's why it has to be greater than 0. Your base has to be bigger than 0. It can be a fraction. It can be less than 1. It just has to be larger than 0 and not be 1. Okay? Okay. Graph is, generally speaking, above the x-axis. There are a few exceptions. We'll talk about them in a minute. Okay? But as a rule, it's above the x-axis. And your y-intercept is 1. So your basic function, your basic a to the x, all by itself, is above the x-axis, and it goes through the point 0, 1. They can be moved, just like anything else can be moved. Okay. Now, if your base is greater than 1, it rises going left to right. It gets larger as you go left to right. If your number is between 0 and 1, let's say 1/2 to the x power, it actually drops as you're going left to right. It starts out tall and it drops going left to right. That's how exponentials work. You have to know what an exponential equation looks like. You have to understand the basics of exponential equations. Okay? You have to know what they look like. You have to know, hey, if I've got some number, a positive number larger than 1 raised to a power, it's going to go like this. And it grows faster and faster. It gets steeper as it keeps going. It never levels out. It always gets steeper. Okay. So let's take a look at some functions and their possible graphs. So a to the x, it would be c. Okay. Your basic one passes through this is your most basic one, a to the x. Your basic function will pass through the point 0, 1. Because when x is 0, what do I have? I have a to the 0, which is 1. So it'll pass through 1. All the rest of these are changes made to that graph. Just like when we take x squared and we add a number, it lifts it up or add or subtract, it lifts it up or down, or it'll move it left or right, or it'll make it fat or skinny. Same things happening here. Okay? So if I multiply it times -2, well, a negative out front is going to do what to it? It's going to flip it down below. Everything that's normally positive is now going to become negative. Okay? So your choices are B or D. And then I look at, okay, if I put in 1 into here, if I put 0 in for x, a to the 0 would be 1 times -2. That will give me where it goes through there on D, which is -2. And then if I look at the next one, a to the x plus 3. So here's my question to you. When we were moving parabolas left and right and up and down, when it was inside the square, what did it do? It moved it left or right in the opposite direction. When it was outside, it moved it up or down. So if I have a to the x plus 3, is that plus 3 inside the function or outside the function?
It's inside.
It'd be inside because it's part of the exponent. So inside moves it left to right, and it always moves it in the opposite direction. So it'd be moving it to the left 3, so that would mean it would be A. And I know by process of elimination, we've only got one left, it would be that. But we also have a couple other things going on. This minus 2a to the x is the same as that. What does the -2 being done on the outside do? It moves it down. That's why this one is D and this one is B. They're the same one with this one being moved down 2 units. Okay. So your shifts are the same shifts you had before, up and down by adding or subtracting outside, left and right by adding or subtracting inside. The 2 is a stretch, and the negative means it flips it over to be up or down. So I don't expect you to be able to graph these exactly by hand, but you ought to be able to have an understanding of what they look like. And this is true for all your basic equations. You need to know what they look like. You need to know what parabolas look like. You need to know what straight lines look like. That shouldn't be a problem. We worked with polynomials. You should have a rough idea of what most polynomials kind of look like. The details in the middle will come later, but hey, you know, they're both up, both down, you know, doing the John Travolta kind of thing. What's going on with that? You understand that a little bit. Exponentials, you need to know if they rise left or right, or they drop left or right, depending upon whether they're plus or minus, what makes them flip up or down. You should have a basic idea what they look like. Okay, this is a big one. Big. The 2 most important numbers in mathematics are pi and e. Okay, pi and e are probably the 2 most important numbers. Pi has some really wonderful, strange things going around with it. Pi pops up in places that you would never think pi would pop up in. You're not talking about trig, you're not talking about triangles, you're not talking about circles, and pi still shows up as solutions for things. Okay, there's lots of ways to generate pi, lots of ways to do it. Pi is a really big deal. It's huge. Okay, E is just about as big. E actually has its own book. I have a book, The Story of E. I kid you not. Actually, it's E, the story of a number. I wouldn't, because I like that kind of crap, but I found it boring as all get out. It was not a well-written book. Yeah, I collect math and science books. I get them and I read them. A lot of them are really good. That one, E, the story of a number, was really boring, really bad, just poorly written. Okay, good ideas, not very well presented. Okay. Now, this is the definition of E. You know the definition of pi. Pi is the circumference of a circle divided by its diameter. That is the definition of pi. 3.141596 is just an approximation. Okay, it goes on forever, never ends, never terminates, never repeats. Okay, E does the same thing. E is also an irrational number. Never terminates, never repeats, just like pi doesn't. Okay. For practical purposes, you don't use that many digits of pi, you don't use that many digits of E. In this class, when you are using pi and when you are using E, unless you are solving a word problem and applying value to that, we generally leave them in terms of E or terms of pi because those are exact values. E is an exact value, and I never remember E off the top of my head because I never use an approximation. 2.7182818828, and it looks like it repeats. It doesn't actually repeat because if you keep going, it doesn't. Okay, but here's the definition of what E is. And E popped up in all kinds of weird places when they discovered the number E. Popped up in all kinds of weird places. And logarithms and exponential growth is where it really applies, where it really came up, but it showed up in other places. This is the definition, and this is an introduction to chapter 2 next year, limits. Okay, we're not going to go into detail here. You will in COP next year. The idea of a limit is what happens. It's called the limit as x approaches infinity. So what they're saying is, what goes on with this as x goes towards infinity? So as I put larger and larger and larger numbers in for x, what happens? Okay, that's what it means. That's what a limit means. So as I put in larger and larger numbers, so if I look at this, put 1 over x, well, as this gets really big, what does 1 over x do? It gets really, really, really small, right? So what's inside here gets really close to 1. It's a little bit more than 1. It's never actually 1, but it's really, really close to 1. But I'm taking a number that's really, really, really close to 1, and I'm raising it to a very, 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 very large power. So I have the insides getting smaller, but the outside's making it bigger. So what happens is and I've done this before, and I've had students do this before with spreadsheets, is take that formula and plug in larger and larger numbers of E. Problem is most spreadsheets start freaking out before it gets very big. Okay. And it goes to approximately 2.718281882. And yes, it looks like it's repeating. It actually is not repeating. As you get farther out, the numbers start switching around again and stuff. For all intents and purposes, if you are using the decimal approximation, you will use your calculator to find E. And E is on your calculator. Okay, E is on your calculator. Yes. That is E. Just like pi is 3.14159, approximately, this is the same thing for E. You will not need to memorize that number, or well, let me put it this way: I don't have that number memorized, and I use it an awful. I use E an awful lot in the last 20 years I've been teaching. I've used it an awful lot. I don't have that number memorized. I have other numbers memorized because I use them so much. I don't remember that one. Why? Because almost everything is in terms of E, and if it's not in terms of E, and I use a decimal approximation, I use my calculator. I let my calculator do the work. Okay. So let's take a look at the question. This is an application to go with it. Okay. So now give me a second to pause this. I meant to pull up a graph. So, okay, if you graph this on your calculator, you do not see the whole picture right away because, let's see if it does. Nope. Okay. If you have it on your window on your calculator, you do not have the entire picture if you have your standard window. All you have is a little tiny little bit that's like right down inside here. That's it. You have to zoom way out to get what happens. Okay? And it says when you reach 6,000 fish. So what I need to do is go to, let's see, 246. Oop.
Oh my gosh, why is he doing it? Wait. Stop.
Yeah. So it's really hard to do on here.
Is it a straight line?
No, it's not a straight line. It's just see, it's not a straight line. But if you zoom in really far, it does have curve to it. Those curves are really sharp. This is what happens with an exponential. Okay. Now, we will go back to, and I'm right. Okay. If we go back and look in here, if TM1 responds to that, what is the population of 6,000 fish? You can graph it or you can solve it algebraically. We're not going to solve this one algebraically today. We will be solving problems like this algebraically sometime next week or the week after. Okay? But if you do that and you trace it on your calculator, which is really hard to do on a calculator, isn't it? You have to put it on trace mode and trace, and you get that it hits 6,000 at about 9.323, which would translate into October. Now, what is the upper limit on the fish pond? Okay. What is the upper limit on the fish pond? What's the maximum number of fish that can live there? And you can get this from the fraction, from what's going on in the bottom. And you can also get it from the graph if your graph goes big enough. Remember what happened to the graph? It went up and then flattened out. Here's what's going on. This is why it flattened out. If I look at this equation, 1 plus 24 e to the negative 2, e to the negative t over 4. 1 plus 24 e to the negative t over 4 power. Okay. Now, if I change that and get rid of the negative, that means I have 1 plus 24 over e to the t over 4 power. Put it in the denominator, get rid of the negative. Let's talk about what's going on here. As t gets really large, what's happening to that power? So e to the t over 4 as t gets really large. Once we get past 4, once we get past 4 months, that's a number larger than 1, right? Once we get past 4 months, it's growing. And how fast does it grow? What do the exponentials do? They start out slow and they get really steep. So this number gets really large really fast. So if I have 24 over something that is tremendously huge comparatively speaking, what is 24, what is this part here going to go towards? It's going to get towards 0, right? Which means this whole thing here is going to get towards 1. Which means if my denominator is 1, what's my capacity? It's 20,000. Because my denominator gets closer and closer and closer and closer to 1. It gets smaller and smaller and smaller and smaller and smaller. So that means the whole thing gets closer and closer and closer to 20,000. Now, in real life, why would that be a good carrying capacity? Okay. Yeah, it's the number of fish. What's going to keep them? What's going to keep a limit on it? The size of the container they're in, the lake, the pond, or whatever. The amount of oxygen that's available. Because you got too many of them sucking down the oxygen, then they're all going to start poisoning each other, and they're going to start dying from that because there's no oxygen anymore. Okay, or they're going to get an overload of plants, or they're not going to have enough food. Every natural system has a carrying capacity for everything. They get screwed up when we come in and start mucking around. And that's why there's deer all over the damn place, because we killed all the bears and mountain lions.
There's a bear in my neighborhood.
I know, they're starting to make a comeback, which actually is kind of cold and kind of dangerous. Okay. Now, let's start solving some problems. Now, these problems are very similar to the ones that you did last year. Solve the exponential equations by getting a common base. So the idea is I want to write them as some number, the same number on each side to an exponent. First thing you do when you look at that is, okay, I've got 4 to some power on one side, 8 to some power on the other side. Is 8 a power of 4?
Yes.
Yeah, but it's not a pretty one. It's some goofy fractional power. We don't want to do that. I don't want to deal with fractions. You want to deal with fractions? No. Can I write 4 and 8 as a power of some common number?
60. Very good.
You're thinking the wrong direction. 2. 4 is what? 2 to what power?
2.
Guys, so I look on here, 4 is 2 squared. So that means I have 2 squared to the 2x minus 1 power equals 8 is 2 to what power? The third. So that means I have 2 cubed to the x power. Now, when I raise power to power, what do I do to the exponents? I multiply them. So I have 2 times 2x minus 1, which means I have 2 to the 4x minus 2 power equals, and here I multiply them here, I get 2 to the 3x power. If my bases are the same, that means if my bases are equal, that means my exponents need to be equal. That means 4x minus 2 equals 3x. Okay. Subtract 4x. Negative 2 equals negative x, so x equals positive 2. So I have 5 and 1/25. What's my base going to be? 5, because I can write 1 over 25 to the 5th power. And as a matter of fact, it's 5 to what power? Negative 2. Okay. Which means that x plus 3 equals negative 2, so x equals negative 5. Easy peasy. Now is when the fun starts. He says as the kids grow faint. What? Wait, what? Okay. All right, here we go on the next one. I have 3 things. I need to combine them up so I have 1 number to a power on one side and 1 number to a power on the other side. If I don't have 1 number to a power equals the same number to a power, I can't drop the bases and set the exponents equal. So I need to figure out my bases that I'm going to get them to. Now, 9, 27, and 1/3. What could be the base for all 3 of those? 3, yes. So 9 is what? 3 squared. So I have 3 squared to the 2x times 3. What is 27? It's 3 cubed to the x squared equals 3 to the negative 1. I don't have 3 on one side, 3 on the other. I got 2 of them. What do I do here to combine them up? I add. First I distribute, then I'm going to add my exponents. So I have 3 to the 4x times 3 to the 3x squared equals 3 to the negative 1. This is 3 to the 3x squared plus 4x equals 3 to the negative 1. When I have 2 things multiplied, I add the exponents. Just because I can't add them together to get one thing doesn't mean I don't add them together. Yes? No, because it's 3 times x squared. Right? Because it's 3 times x squared, which is 3x squared. 9x squared. No, you don't multiply here. What do you do? What? Shh. The rules of exponents. When you have two numbers raised to a power of the same base, do we double the base? Do we do it in the base? No, you just add the exponents. Go back to the rule. Very common mistake. So now I can do 3x squared plus 4x equals negative 1. What do I need to do to solve that? Set it equal to 0. 3x squared plus 4x plus 1 equals 0. And then you factor and you solve. And you end up getting x equals negative 1 and negative 1/3. When you're all said and done. I'm going to leave the factoring and stuff to you guys. All right, next one. Looks all spooky and scary, doesn't it? It does exactly the same thing as the other ones did. The difference is that my base is E instead of some other number. It's just a number. E is just a number. Just like pi is just a number. A very special number, but it's just a number. My rules of exponents don't change. Okay, my rules of exponents don't change. So I do the same thing here. So I have e to the negative x squared equals e to the 2x times e to the negative 3. E to the negative x squared equals e to the 2x minus 3. What do you do when you multiply with the same base? You add the exponents. Now I have e to some power and e to some power. That means negative x squared equals 2x minus 3. Set it equal to 0. I would move the negative x squareds. You want to have your x squareds be positive whenever possible because it makes factoring so much easier. Not to mention quadratic formula. 0 equals x squared plus 2x minus 3. You factor, set each factor equal to 0, and you get x equals negative 3 and 1. So you want to know where to find, how many of you found e on your calculators?
I found it.